Good day, this is Mr. Keaton talking to you today about proving lines parallel. And in chapter 3.2 we had, if two lines are parallel, we had corresponding angles are congruent. That was this theorem right here. And there were various other theorems that went along with if two lines are parallel, alternate interior angles are congruent. We had alternate exterior angles are congruent. And we had same side angles inside sum to 180. That's if two lines are parallel. In chapter 3.3 we do the converse, which means we work it backwards. If corresponding angles are congruent, then the two lines are parallel. It's just working it backwards. And the same thing applies to those other theorems. If alternate interior angles are congruent, then parallel lines. So we can work it backwards also. And so we have the same theorems that we had in 3.2, just the converse, which means we're working it backwards. So in this problem it says, find the value of y that makes A parallel to B. So we want to make A parallel to B. For that to be true, the alternate exterior angles must be congruent. So we can say 5y plus 6 equals 121, and go ahead and quickly solve for y, giving us 5y's 115, and divide by 5, y is equal to, what is that, 23. And so we found our y value that makes A and B parallel. Once again, to make A and B parallel, we symbolize that by putting arrows on these lines, A and B. Going to the next slide. Marie was stenciling the design, her kitchen walls. How can she tell if the top and bottom lines of the designs are parallel? Well, she's going to have something be congruent to each other. Alternate interior, alternate exterior, but if she wants these two to be parallel, we're probably going to have to work on having alternate interior angles. So I could say, let's make angle 4, the measure of angle 4, congruent to the measure of angle 3, and then we'd have parallel lines. What else could she do? She could, that's about it on that, isn't it? So using alternate interior angles. Angles are congruent. Going to the next slide, let's see what we got here. Oh, we have a proof. This one's already done for us. We'll just walk through it. It says prove that angle 1 and angle 4 are supplementary. Then A is parallel to B. So we're going to prove that. So given angle 1 and angle 4 are supplementary, so we could first state that they're supplementary. That was given. And then we could look at angle 1 and measure of angle 1 plus the measure of angle 4 by the definition supplementary equals 180. Just converting it to measures, definition supplementary. And now we can look at, let's go ahead and change. These two are also supplementary, so that's measure of angle 3 plus the measure of angle 4 is 180. That's a linear pair definition. And they did the same thing with 1 and 2 by linear pair definition. And now they're using the addition property of equality, and they're adding both of those together, giving measure of angle 3 plus the measure of angle 1 plus the measure of angle 4 plus the measure of angle 2 equals 360. They added these two equations together here. And now, using substitution property from up here, they substitute 1 and 4 in for 180, and then so that gives us a measure of angle 2 plus a measure of angle 3 equals 180, because this is 180, this is 180. They subtracted it from both sides, subtraction property of equality, and we're able to get the measure of angle 2 plus the measure of angle 3 equals 180. And that tells us this one plus this one sum to 180, which means they're parallel lines because we have same side angles add to 180, or consecutive angles adding to 180, hence the lines are parallel. Going to the next one, we'll stop here and redo this in a second.